Imagine you're sprinting down a hallway, wind in your face, heart pounding, shoes slapping the floor like they are trying to file a noise complaint. You are moving fast, but time? Time is not impressed. Time is leaning against the wall, sipping cosmic coffee, raising one eyebrow like a parent watching a toddler attempt parkour. Because here is the strange, slightly rebellious truth about the universe. The faster you move, the slower time moves for you. It sounds like something cooked up by a philosopher who had one too many cups of quantum strength espresso, but it is real, measurable, and one of the universe's favorite pranks. It is almost like the universe pats you on the head and says, "Slow down, speedster. If you keep pushing the pedal, I am going to stretch your minutes like taffy." Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now, let's begin. We are used to thinking of time as a steady drumbeat marching along with absolute confidence. You wake up, hours pass, the sun crosses the sky. You wonder how it is already evening again, and the cycle repeats. Time is supposed to be the one thing that does not change its mind about how fast it flows, except it does. Time is a lot more flexible than humans give it credit for. It bends, it stretches, it slows down, and it does all this without a hint of apology. Motion, particularly fast motion, tugs at time like a mischievous kid pulling on a sweater sleeve, making it stretch out in ways that feel almost magical. The first time you hear this idea, it feels like someone is breaking a rule you did not know existed. How can time move differently depending on how you move? Shouldn't time be the same everywhere, like the gravitational pull of pizza on human cravings? But the universe does not care about human expectations. It simply follows its own set of cosmic rules. And one of those rules is that your experience of time depends entirely on your speed. It is one of the few moments in physics where reality leans over and whispers, "By the way, nothing is as simple as you think." Picture yourself sitting perfectly still in a chair. Time around you flows at what feels like its normal pace. You might scroll your phone, blink, breathe, or contemplate why socks disappear in dryers, and every second ticks along predictably. Now imagine yourself suddenly zipping off at a significant fraction of the universe's ultimate speed limit. As your motion increases, something subtle and astonishing begins to happen. You still feel fine, maybe exhilarated, maybe focused, but time starts to drag its feet just for you. To everyone else watching, your clock ticks more slowly than theirs. Seconds for them are slightly longer for you. Their minutes stretch out while yours compress into something almost slippery. If you could step outside yourself and watch your life from a cosmic balcony, you would see that fast motion does not simply carry your body toward a destination. It drags your personal timeline along for the ride, reshaping it like soft clay. And even though nothing about your heartbeat or thoughts would feel different, the universe's bookkeeping would show that you have lived a tiny bit less than someone moving more slowly. Imagine going on a high-speed journey and returning home to find that everyone has aged more than you. You would look around and say, "Did you all start using a different brand of calendar while I was gone?" That is the effect of motion messing with time. The idea itself feels absurd in that delightful way that reality often feels absurd once you look at it closely. Motion slowing time sounds like something a science fiction movie would use as a plot twist, right before revealing the villain is actually a time-traveling houseplant. And yet this is no fictional concept. The universe does not care if it seems strange. It simply works this way. You move fast, and time slows down. Slightly, subtly, but undeniably. What makes this idea even more fun is the fact that nothing about your personal experience gives it away. You do not feel your time dragging. Your thoughts do not slow. Your heartbeat does not stretch out like a lazy sloth. Everything inside you feels perfectly normal. It is only when comparing your timeline to someone else's that the difference becomes clear. It is like two people reading the same book in separate rooms, turning pages at different speeds without realizing it. Only when they meet do they discover one is far ahead in the story. Think of time as a river, but not one with a smooth, gentle flow. This river shifts its current depending on how you move through it. Sit still, and the river flows peacefully. Move fast, and the river rearranges itself around you, pulling back its currents so that your journey through it becomes slower. You do not notice the change because you are in the water. But someone watching from the riverbank sees everything, sees how your little boat glides more slowly through the flow the faster you paddle. That is the hook, the doorway, the starting point for our long journey into understanding why time behaves this way. Because the moment you realize that motion can stretch time, you begin to understand that the universe is far more flexible, surprising, and mischievously intelligent than it first appears. And once you take that first step, you cannot help but wonder what else time is secretly capable of. There was a moment in scientific history when the universe revealed that it had far more personality than anyone expected. And that moment arrived courtesy of a young patent clerk who kept questioning the things everybody else seemed comfortable accepting. Einstein was not strolling through marble hallways or lounging in an observatory when the idea struck him. He was sitting in a modest office, stamping documents, while his mind sprinted far past anything human legs could manage. It is strangely fitting that the theory rewriting the flow of time itself began with a man stuck at a desk, longing for mental escape velocity. Before Einstein, time was treated like a cosmic grandfather clock that ticked away with perfect commitment. If two people looked at the second hand from different corners of the universe, they would assume it moved identically for both of them. No exceptions. Time was so deeply believed to be universal that questioning it felt like asking whether water was actually wet. Scientists treated time with reverence, like a stern schoolteacher whose rules were never to be challenged. Einstein, however, had a habit of squinting at ideas that seemed too tidy. He started wondering what the universe looked like from the perspective of light itself. Imagine chasing a beam of light, sprinting so fast that you try to match its pace. What do you see? What happens to the wave of light in front of you if you somehow keep up with it? The thought experiment sounds like bedtime reading for insomniac photons, but the more Einstein poked at it, the more the universe's seams began to show. If you could move alongside a beam of light, Einstein realized, you would expect to see something weird, something that broke the old rules. The light wave should look frozen in place, like a cosmic sculpture suspended mid-motion. But according to the laws of nature known at the time, light was never supposed to behave that way. The contradiction bothered him like a mosquito that refuses to stop circling your ear. If light must always move at the same speed for everyone, then something else had to give. Einstein's conclusion was elegantly rebellious. The problem was not with light. The problem was with time. Time, he proposed, was not a universal rhythm, but a flexible property that changed depending on your motion. It was not a rigid metronome, but a very patient rubber band, stretching or compressing to keep the universe's rules consistent. The idea was revolutionary, almost impolite in its boldness. If time could stretch for someone who moved fast, then no two observers were guaranteed to experience the same flow of seconds. The universe was no longer a single synchronized wristwatch, but a collection of clocks that could run at different paces without ever breaking the laws of physics. Einstein framed this in a way that felt almost poetic. Space and time were not separate entities. They were woven together into one fabric. If you tugged on space by moving quickly, time had to adjust itself to maintain the integrity of the fabric. It is like sitting on a trampoline and having a friend jump on it. You do not remain perfectly still just because you want to. The fabric reshapes itself whether you approve or not, and you move accordingly. That is precisely how time behaves. If motion stretches the space-time trampoline beneath you, time obligingly shifts its speed, as if saying, "Fine, I will go slower, but only because the universe demands it." Einstein's insight did not arrive with fireworks or a chorus of triumphant trumpets. It emerged quietly from layers of thought, each one peeling back the assumptions people had held for centuries. He realized that the speed of light is the anchor point of the universe. Everything else must adjust to preserve that constant. Time stretches, distances contract, and clocks slow down, all to protect that fundamental speed like loyal bodyguards. The brilliance of his idea was not just in questioning time, but in showing that nature plays by consistent and surprisingly considerate rules. If you run faster, your time must slow down to keep the cosmic mathematics balanced. It is not a punishment, it is symmetry. It is the universe making sure everything lines up neatly, even if humans find the consequences jaw-droppingly strange. Einstein described his theory not as the invention of a new idea, but as the discovery of something that had always been true, hiding in plain sight. Time had never been stiff or inflexible. It had always been elastic. Humanity had simply never pushed hard enough against it to notice the stretch. The beauty of this realization is that it reshaped everything, not with flashing special effects or thunderous announcements, but with quiet, logical inevitability. Once you accept that the speed of light must remain constant for all observers, time itself must become negotiable. It must flex, bend, and warp. And once you understand that, the entire universe becomes a more dynamic place, a place where the fundamental rhythm of existence depends on how you move through it. Einstein looked at the cosmos and saw that time is not an absolute ruler, but a cooperative one, adjusting itself with remarkable grace. He gave the universe a personality, not a chaotic one, but a clever one. A universe that keeps the rules consistent, even when the details seem bizarre. And from that realization came the beginning of modern physics' most astonishing truth. Time does not just pass. It participates, it reacts, it stretches like the most patient rubber band in existence, maintaining order even as you race through its fabric. If the universe had a set of traffic laws, the first and most dramatic one would be posted on every cosmic street corner in glowing letters. Nothing outruns light. The speed of light is the grand, untouchable speed limit, the kind that makes all other speeds look like they are wearing training wheels. Light zips along faster than anything humans have ever built, imagined, or accidentally launched into a neighbor's yard. And the fascinating part is not just that nothing can go faster, but that everything in the universe seems designed to protect that limit with the same intensity as a librarian guarding the quiet section from a group of overly enthusiastic drummers. What makes light speed so special is that it does not act like an ordinary number. Most limits are negotiable. You can exceed a speed limit on a highway if you hit the gas too hard. Not recommended, but physically possible. With light speed, the universe simply refuses to let you approach it casually. You can push, accelerate, pour energy into an object, and the object will get closer and closer to light speed, but never reach it. It is like trying to catch up to a treadmill that automatically speeds up whenever you do. No matter how much effort you apply, the finish line sprints ahead with a smug expression. The closer you get to this ultimate limit, the more reality tweaks itself to keep everything consistent. And one of the most surprising tweaks is what happens to time. As you speed up, time begins behaving like a lazy cat that has absolutely no interest in keeping pace with you. It stretches out, slows down, and takes a nap in the sun while you are trying to break records. You can pour in more energy to go faster, but time keeps dragging its paws, refusing to cooperate. To understand why this happens, imagine that the universe has a rule book it refuses to break. In that rule book, the speed of light is the ultimate non-negotiable law. Everything else, time, space, energy, must adapt to preserve that one rule. So when an object accelerates, space and time become the flexible parts of the system. They shift and warp to make sure the laws remain balanced. Motion, in a sense, disturbs the fabric of spacetime, and time adjusts itself to calm the disturbance. As you approach higher speeds, your time slows down, not because the universe is punishing you, but because it is preserving harmony. Time is like a very stubborn cat that refuses to jump off your lap when you want to stand up. It simply digs in deeper, declaring, "I move at my own pace, thank you," and forces everything else to work around it. The faster you try to go, the more time resists, stretching out your seconds like warm taffy. This slowdown is not symbolic. It is real, physical, and measurable. If you could fly in a spacecraft that reached an unbelievably high speed, perhaps 99% of the speed of light, your time would pass more slowly compared to people watching safely from home. You would live normally from your perspective, breathing, thinking, daydreaming, but your seconds would be stretched. Time would stroll for you while it jogged for everyone else. What makes this effect so fascinating is its quiet subtlety. Time does not announce its slowdown. There is no cosmic voiceover saying, "Warning, you have entered the region of dramatic temporal stretching." To you, everything feels completely normal. You are the lazy cat in your own frame of reference, lounging happily while the rest of the world seems hyperactive by comparison. While this all sounds whimsical, the reason behind it is one of the universe's deepest commitments, keeping the speed of light constant for every observer, no matter their speed. It is as if the universe agreed that light must always be the star of the show, always hitting the same speed mark in every scene, no improvisation allowed. To make that happen, the rest of reality flexes its rules. Time takes the flexible role, bending to maintain the cosmic consistency. One way to imagine this is to picture the universe hosting a cosmic race where light is the undefeated champion. Everyone else can join the race: particles, ships, cosmic dust, curious humans with a dramatic sense of adventure. But the rules guarantee none of them will ever tie with light, let alone outrun it. As you run faster, the racetrack itself stretches, time slows, and the finish line discreetly moves farther away. The race becomes a test of endurance, not speed, and the universe politely watches you attempt the impossible with gentle amusement. This speed limit is not just a quirky feature. It is essential to how everything works, from why atoms behave the way they do, to how cause and effect unfold. If it were possible to exceed light speed, the neat ordering of events could break down, and the universe would become a place where clocks lose their sanity. The cosmic speed limit preserves structure, logic, and chronology. It keeps the universe from slipping into chaos like a poorly organized card trick. And there is a deeper elegance hidden in this rule. By slowing time for fast-moving objects, the universe ensures that no one ever experiences a contradiction in physics. It is a perfect balancing act. You can get as close to light speed as you want, but time will stretch, space will contract, and energy will climb into astonishing levels to guarantee that you never break the rule. It is the universe's way of saying, you can come close, but I am keeping this last boundary for myself. So the cosmic speed limit is not just a number. It is a guardian of structure, a sculptor of time, and the reason the universe remains a coherent story instead of an unraveling plot. And as you rush toward that ultimate speed, time does what it always does when things get dramatic. It curls up, gets comfortable, and politely refuses to keep up. There is a certain moment in every physics story where the universe seems to clear its throat and admit that it has been hiding something slightly embarrassing. In this case, what it hides is that distance itself is not as fixed as humans like to pretend. We treat distance as something solid and unmoving, the dependable part of reality you can measure with a ruler, tape measure, or the classic eyeballing it and hoping for the best. But once you start moving fast, really fast, the universe starts shuffling its feet, adjusting hems and seams, and quietly altering the very idea of how far things are. It is like watching an actor on stage who suddenly realizes the spotlight is pointed 2 feet away from where they rehearsed. And now they have to shift their weight and pretend this is all part of the performance. When you move through space-time, you are not just drifting through a silent void. You are interacting with a fabric that responds to you, almost as though you brushed your hand across a curtain and it rippled in acknowledgement. This fabric is a strange one, stitched together from the threads of space and the threads of time. And just as fabric stretches differently depending on how you pull it, space-time reshapes itself depending on how you move. At low speeds, the gentle jogging pace of daily life, these shifts are microscopic. You can walk, run, or crash a grocery cart into a display of oranges without ever noticing space-time altering anything to accommodate your motion. But when your speed climbs to fractions of the cosmic limit, the fabric stops pretending. It starts shifting its weight, readjusting its stance, and behaving like it suddenly remembered it has opening night jitters. One of the strangest things the universe does in this scenario is compress the distances in the direction you are traveling. The effect is called length contraction, which sounds like a fitness plan for objects trying to become more aerodynamic. But it is far weirder than that. As you speed up, the space in front of you actually becomes shorter from your perspective. The journey that once looked impossibly long begins to shrink, folding itself slightly to make room for your velocity. To someone watching you fly by, the spaceship or object you travel in also appears squished along the direction of motion, like a loaf of bread someone pressed too hard. This does not happen because objects physically crush themselves out of fear of going fast. It happens because space-time adjusts its measurements to keep everything internally consistent. The fabric changes how it defines distance, the same way an overwhelmed actor shifts from one foot to the other when too many people stare at them. It is an attempt to maintain balance under pressure. Simultaneously, time begins to adjust itself as well. Your clock ticks differently when you move quickly, but the odd part is that distance and time do not change separately. They change together, like two actors improvising a scene so well you almost forget the script was never written that way. When one shifts, the other must shift in a complementary fashion to preserve the story of cause and effect. It is a synchronized dance that unfolds without anyone consciously noticing. This dance is necessary because the universe insists on consistency. If you move faster, distances contract. If distances contract, your perception of how long things take must also change. The universe does not allow mismatched accounts where one traveler says the journey took ages, while another insists it only took a cosmic minute, unless their clocks and rulers have also adjusted in exactly the right way. Space-time handles all of this silently, with the efficiency of a backstage crew rearranging props without ever appearing in the spotlight. What makes the whole phenomenon even stranger is that none of it feels unusual from your own point of view. You do not feel squished. You do not feel distances compressing in your direction of travel. You do not sense time doing interpretive dance around you. Everything inside your personal frame of reference remains calm, normal, predictable. The universe politely makes all its adjustments in the background, like a maitre d' quietly fixing the tablecloth while you sip your drink unaware. But from an outside observer's perspective, everything about your motion becomes wildly different. They see your clocks ticking slower. They see the lengths of objects in your direction of travel shrink. They see spacetime bending itself to keep up with your velocity. And depending on how fast you go, these distortions can become dramatic. Not subtle whispers, but bold statements that the fabric of reality is much more flexible than anyone assumed. This is where the uncomfortable actor metaphor becomes especially fitting. Space-time is trying to maintain composure, trying to make sure the story makes sense from every perspective. When you start sprinting toward the cosmic speed limit, space-time feels the metaphorical spotlight shift. It must adjust. It must shift its weight, rearrange its distribution of distances and durations, and present a performance that remains logically coherent. It does not do this reluctantly. It does this because it must. Space and time are not independent components. They are threads in a single tapestry, pulling on one thread by moving quickly, tugs at the others. And the result is not chaos, but choreography. In a way, the universe behaves like a director who insists that every angle of the scene must align, every actor must land their line at the right moment, and every motion must fit the tone of the play. When you move fast, space-time simply adjusts the set behind you. Distances contract to keep pace, time adapts to maintain consistency, and the entire stage bends just enough to ensure nothing breaks. So moving fast is not just a journey through space, it is a negotiation with the fabric of reality. Every step you take, every acceleration you push, makes the universe shift its stance ever so slightly, like an actor realizing the audience is watching closely. And in that subtle shift, the laws of physics reveal themselves not as rigid commandments, but as flexible rules that adjust just enough to keep the whole cosmic performance running smoothly. Step inside the spaceship, not a clunky metal box with flickering lights and loose screws, but a sleek, humming vessel built for a journey that brushes the edges of the universe's speed limit. The moment the doors slide shut, the outside world quiets. Inside, everything feels calm, almost strangely ordinary, like stepping into a library where even the engines seem to whisper. Nothing about this interior hints that you are about to bend time around you like a warm piece of saltwater taffy. The engines engage with a gentle push that feels more like an invitation than a shove, and suddenly the stars outside smear into elongated streaks. It is not because they are actually stretching like cosmic paint strokes. Your mind simply has no experience to compare this kind of acceleration to. So it interprets the universe as if someone grabbed the night sky and dragged it sideways. The ship climbs toward extraordinary speed, brushing past thresholds where everyday physics starts backing away like, okay, this part is above my pay grade. As you settle into your seat, You glance at the clock mounted above the control display. It ticks with the same confidence it always had. Each second feels like a normal second. Your heartbeat keeps its steady rhythm, your breathing remains unchanged, and your thoughts wander at their usual pace, drifting between curiosity and the mild concern of whether you remember to turn off your apartment lights before leaving. Nothing inside you hints that anything unusual is happening to time itself. But if someone outside the ship could peek at your clock, they would see something wildly different. They would see each tick happen more slowly. To them, your seconds are stretching out, drifting past like lazy balloons meandering upward with no urgency. Your time has begun to crawl compared to theirs, but you cannot feel it. Inside the ship, your internal rhythm stays stubbornly normal, as if you exist inside a cocoon where the universe cannot quite tap you on the shoulder. The strangest part is that the ship's interior feels completely honest. The lights do not flicker in slow motion. Your coffee does not hover above the cup like a philosophical droplet questioning its life choices. Everything obeys your personal timeline because your entire environment is moving with you. It is like you and the ship have agreed to ignore the universe's broader schedule. You have created your own little pocket of time, one that insists the outside world must be exaggerating. Meanwhile, outside the ship, the universe is racing forward with astonishing speed. Planetary orbits, drifting dust clouds, slow-burning stars. All of them march along their regular timeline. If you could look out the window and somehow perceive time outside your bubble, it would feel like watching the universe on fast forward while your own clock takes its sweet time. It is as if you decided to stroll casually through life while everything else sprinted past, waving as it accelerated into the distance. This discrepancy is not metaphorical. It is real enough to measure with perfect accuracy. If you stayed on this high-speed journey long enough and then returned home, you would find that far more time has passed for everyone else than for you. Maybe decades, maybe centuries. You would step out of your ship feeling only slightly older than when you left, like someone finishing a long nap, while the world you knew would be a distant historical footnote. You would become the traveler who leaped over entire eras simply by moving fast. Inside the ship, the realization slowly dawns that time dilation is not just a dry equation buried in physics textbooks. It is something you are living through moment by moment. When you adjust the navigation panel, your fingers glide across the controls with their usual grace. When you stretch your arms, the motion feels natural. But the universe is keeping meticulous records in places you cannot see. It is tallying every second differently for you than for the rest of existence, as if it keeps two separate ledgers, one for the traveler and one for the stationary observer. The higher your speed climbs, the more dramatic the difference becomes. The ship approaches a level of motion where the universe politely but firmly insists, if you are going to keep accelerating, I am going to slow your time down even more. But it never feels oppressive. It feels like floating in a cushion of reality that has agreed to bend around you. The engines hum, the navigation lights pulse gently, and your thoughts wander across the vastness of space uninterrupted. There is something haunting yet beautiful about realizing that the universe grants you this kind of temporal detachment. While you drift between stars at extraordinary speed, time becomes something flexible, something that adapts to your journey instead of dictating it. You become a traveler slipping between the ribs of cosmic history, untouched by the normal aging of the world you left behind. And the best part? Every sensation you experience still feels completely ordinary. Time does not tap you on the shoulder and whisper, "By the way, I am stretching for you." It simply does it, quietly, consistently, with the calm confidence of a universal rule that knows it does not need to prove itself. Inside the high-speed ship, your life feels continuous and familiar. Outside, the universe is sprinting. The clocks disagree, but neither feels wrong. They live in two different truths, both valid, both real, both woven into the same cosmic tapestry. And that realization, sitting alone in a humming vessel while time bends gently around you, is perhaps the closest a human can come to experiencing the universe's deepest poetry firsthand. Imagine two twins who have lived identical lives up until this moment. They share the same birthday, the same childhood mischief, and the same talent for arguing about who stole whose socks. But today, something changes. One twin, let us call them the restless one, decides that ordinary life is too slow. This twin looks at the sky and thinks, "What if I took a quick trip across the galaxy? You know, like running out for milk, except the milk is starlight and the store is a few light years away." The other twin, more grounded, decides to stay home and tend to earthly responsibilities. And so this becomes the beginning of the universe's most dramatic sibling experiment. The restless twin boards a spacecraft designed for extreme velocity, something sleek enough to make even starlight do a double take. They wave goodbye with the energy of someone who fully intends to return with cool souvenirs. The stay-at-home twin waves back with the energy of someone who hopes those souvenirs do not involve alien paperwork. When the engines ignite, the spacecraft leaps forward like a comet that just remembered it had somewhere important to be. But this is not an ordinary trip. This is a journey near the universe's speed limit, where time changes its behavior in ways no human intuition is prepared for. As the traveling twin accelerates, time inside the ship begins to dilate. It stretches in a way that is subtle in experience but profound in consequence. Seconds feel normal, minutes tick by like any other day. But the universe outside the ship keeps a different tempo, one that races ahead like it has double espresso for bloodstream. Meanwhile, back on Earth, the grounded twin continues life at the usual pace. They go through seasons, celebrations, disappointments, birthdays marked by candles that never seem to agree on how many there should be. They glance at the night sky sometimes, wondering how far their sibling has traveled. But on Earth, time remains steady, unbent, unwarped, untroubled by cosmic speed. The traveling twin, on the other hand, experiences something stranger than fiction. The higher the speed climbs, the more dramatically their time slows relative to Earth. It is not something they feel, no slow-motion blinking or overly dramatic echoes in their mind. Their body and thoughts stay perfectly synchronized with their own clock. But space-time is keeping score, and the scorecards are beginning to diverge. To imagine what this difference feels like, Picture the traveling twin watching a recording of Earth's timeline, if that were somehow possible. The footage would seem accelerated. Days would flip past like pages in a book someone is skimming too quickly. Clouds would swirl and vanish. Cities would spread like glowing moss. Entire generations might rise and fall in the span of a personal year. Meanwhile, the traveler sits inside a ship where each moment unfolds at its usual measured pace, sipping water, adjusting controls, stretching legs, humming favorite songs that haven't had time to go out of style. This imbalance reaches its most dramatic moment when the traveler finally announces, "All right, galaxies explored, cosmic errands complete, time to go home." They rotate the ship, fire the engines, and head back toward Earth. The return journey follows the same rules. While the ship moves fast, the traveler's time continues to stretch, as if the universe is gently tugging at their seconds, like a tailor letting out a seam. Back on Earth, the grounded twin's life keeps rolling forward, uninterrupted. They might imagine grand reunion speeches or emotional slow-motion hugs. They might even assume the traveler will return looking more weathered, having endured the harshness of space. But spacetime has prepared a plot twist worthy of a cosmic drama. When the spacecraft finally descends into Earth's atmosphere, it is greeted as though someone has returned from legend. People gather in anticipation. The grounded twin stands at the front of the crowd, looking older, noticeably older, with lines on their face that tell stories the traveling twin did not live through. The ship lands. The doors hiss open, and out steps the wanderer, looking only slightly older than when they left, as if the trip were a long weekend rather than a generational saga. This is the paradox that is not really a paradox once you understand the rules, but feels like one because it contradicts every instinct humans have about aging. One twin lived at everyday speed. The other skimmed near light speed, where time slowed itself to match the motion. They did not cheat time. They simply experienced a version of it, sculpted by velocity. The grounded twin might say, "How is this possible? I have lived decades. You have lived years." And the traveling twin might shrug helplessly, because from inside the ship, nothing unusual ever occurred. Time never felt stretched or compressed. It simply unfolded differently, depending on which path each twin followed through space-time. Standing side by side now, they resemble two branches of a story that diverged and reconciled only to reveal that time is not a uniform river. It is a landscape you move through. Walk slowly, and the scenery passes at a gentle pace. Sprint near light speed, and the scenery becomes a blur, while your own steps seem unchanged. When you finally stop, you discover the world has moved on without you. Not because anyone was impatient, but because your path bent the very fabric of duration. The twin paradox is not just a physics lesson. It is a tale about how the universe keeps its promises, even when those promises look impossible to human intuition. It shows that time does not treat all journeys equally. And when you step back and see the twins standing together, one aged by the quiet persistence of Earth's timeline, the other marked only lightly by the passage of their own stretched moments, you understand that motion is not just travel. It is a way to sculpt time itself, like an artist carving seconds into a shape no one else can wear. If you want to see time dilation at its most dramatic, you do not start with spaceships or twins or heroic journeys across the galaxy. You start with something much smaller and far less glamorous, unstable subatomic particles that blink into existence and disappear again before you can even form the thought, well, that was fast. These particles do not lead cinematic lives. They do not star in sweeping space odysseys or deliver tearful speeches about the nature of time. They simply pop into the universe, exist for a fraction of a blink, and vanish. And yet, despite their tiny lifespans, they have taught us some of the most profound truths about how the universe treats aging when motion enters the picture. One of these particles is the muon, a sort of heavier cousin of the electron that behaves as if it is constantly late for an appointment in a universe that has no clocks. A muon typically lives for an incredibly short duration before decaying into other particles. Under normal everyday conditions, a muon's life is so brief that it could fit comfortably inside a whisper. If the universe handed out awards for least likely to attend their own retirement party, muons would win every year. But as short-lived as they are, muons become remarkably interesting when you place them inside a particle accelerator, massive machines that swirl particles at extreme speeds until they are moving so fast that everyday physics begins to sweat nervously. Inside these accelerators, muons are propelled to velocities that skim just under the speed of light. They whip around arcs of magnetic fields with such enthusiasm that if they had hair, it would be permanently stuck backward. Here is where the magic happens. A muon's internal clock, whatever passes for a clock in something so small and fleeting, is supposed to tick toward decay at a predictable rate. Yet when you accelerate a muon to extraordinary speeds, that internal countdown slows down. It slows dramatically. These particles, which usually vanish almost immediately, linger. Not metaphorically linger, literally linger. They live longer simply because they are moving fast. It is as if time itself says, "You seem to be in a hurry. I will just slow down for you, no problem." Imagine a tiny particle rushing along with cosmic urgency, and the universe responds with the politeness of a maitre d' holding the restaurant door open. Time stretches for the muon, allowing it to enjoy a longer existence, not by choice, not by miracle, but by the unavoidable rules of the cosmos. This effect was not discovered through speculation or philosophical musings. Scientists watched it unfold in real experiments, with measurements so precise they could make a perfectionist weep with joy. When muons are produced high in Earth's atmosphere by incoming cosmic rays, they should not have enough time to reach the surface because their normal lifespan is too short. But they do reach the surface in astonishing numbers. Why? Because they are traveling so fast that their time is stretched out. Their personal clocks are ticking lazily, like they decided to enjoy a cosmic hammock while roaring toward the ground at an unimaginable pace. That was one of the earliest natural hints that motion bends time. But particle accelerators gave humans the ability to create the effect on demand. under controlled conditions, with clear before and after comparisons. Scientists would generate muons, record how fast they decayed when at rest, then accelerate them to incredible velocities, and watch the same muons stubbornly refuse to die on schedule. The difference was not subtle. It was dramatic, unmistakable, and impossible to dismiss. Inside the accelerator, the muons live many times longer than their standard lifespan. Their decay is delayed in direct proportion to their speed. The faster they are pushed, the more patient time becomes. It is the perfect scientific demonstration because it shows the effect cleanly. No philosophical debates, no interpretive metaphors, just particles breaking their own expiration dates because the universe is bending time around them. The elegance of this phenomenon lies in its simplicity. Muons have no awareness. They do not adjust behaviors or strategize survival. They do not think, if I accelerate, perhaps time will stretch for me. They just move. And the universe, guided by the logic imprinted in its deepest structures, adjusts time in response. This is not something that requires consciousness. It is automatic, mathematical, inevitable. Imagine standing outside the particle accelerator and watching the muons whirl around. From your perspective, those particles should have decayed long ago. You might say, those muons must be incredibly stubborn. But inside the frame of the muon, each one is living a perfectly normal lifespan. Nothing feels stretched or unnatural. Its internal processes unfold at their usual pace. It decays when it is supposed to decay, but because its personal seconds are slower, its death arrives later according to you. Two valid realities, two timelines, coexisting without contradiction. This makes particle accelerators one of the most extraordinary laboratories for watching time dilation in action. Humans cannot test these speeds on themselves, but particles can. Particles endure the acceleration humans cannot tolerate. They survive conditions we would never experience. And by their behavior, they tell us exactly how the universe bends time under extreme motion. So the next time a muon streaks through a detector, living a life far longer than nature normally allows, remember what is actually happening. That tiny particle is racing through space-time so quickly that the universe steps aside, slows its internal clock, and allows it to linger. It is the smallest of creatures receiving the grandest of cosmic courtesies, proof that motion can stretch time even for something that barely gets a chance to exist. If you ever want to witness a tiny tug-of-war between gravity, motion, and time, you do not need a galaxy-sized laboratory or a spaceship punching its way toward the speed of light. All you have to do is look up, not at the stars, not at distant nebulae, but at something much closer, a metallic home circling Earth every hour and a half. The International Space Station may look like a floating science condo, but it is actually one of the most delicate arenas where time itself negotiates its rules. Astronauts on board the station are not just floating, they are falling. They spend their days in a controlled free fall around Earth, looping through orbit so quickly that the planet's surface seems to glide underneath them like a conveyor belt of oceans, cities, and continents. This motion alone is enough to stir time into doing one of its subtle tricks. But motion is only half the story. Gravity, always eager to participate in cosmic mischief, joins the conversation too. The station orbits a little over 400 kilometers above Earth, close enough that gravity still has a strong grip, but far enough that the grip loosens just slightly. You can think of gravity as a cosmic hand. At Earth's surface, the hand holds you firmly. Up where the station floats, the hand relaxes, still touching, but no longer squeezing. That relaxation does something strange to time. It speeds it up, just a little. Gravity bends time downward, like a heavy weight pressing on a trampoline. When the weight is lighter, the bend is shallower, and time flows slightly faster. So the astronauts find themselves in a curious position. Their tremendous orbital speed tries to slow their personal time down, while the gentler pull of gravity tries to speed it up. It becomes a gentle, ongoing negotiation. A cosmic accountant tallying motion on one side of the ledger and gravitational relaxation on the other. The result is that astronauts experience a very slight difference in time compared to people on Earth, a kind of microscopic temporal toll, a time tax. What is remarkable is that the two effects work against each other. The high speed of orbit pushes astronaut time slower by a whisper. The reduced gravity nudges astronaut time faster by another whisper. Add them together, and the gravitational nudge actually wins by a hair. The astronauts age a little faster than their Earth-bound counterparts, though the difference is so ridiculously small that you would need more than patience. You would need extremely precise clocks and a deep fondness for decimals. Still, the effect is real. If an astronaut spent 6 months living on the station, they would return having aged a tiny sliver more than someone who spent those same 6 months on Earth. Not a dramatic science fiction difference. We are talking milliseconds, not missed birthdays. But in the universe's eyes, even a millisecond is meaningful. It proves that motion and gravity are constantly nudging and nudging back, shaping time with a tug so gentle that the astronauts never feel it. Inside the station, life goes on without any hint that time is playing favorites. Astronauts drift through modules in slow arcs, pushing themselves from one handle to another like polite pinballs. Their days are full of experiments, maintenance tasks, exercise routines designed to stop their bones from filing complaint forms, and moments of quiet awe staring at Earth through cupola windows. Nothing about their heartbeats, thoughts, or conversations gives away that time is pouring through their world at a slightly adjusted flow rate. And of course, the astronauts measure everything with clocks that move right along with them. To them, the pace feels normal. A second lasts a second. Coffee brews at the same speed. Jokes take the same amount of time to land. If someone called them from Earth and announced, "Your time is moving faster than ours," the astronauts would raise an eyebrow and reply, "Funny, because we are not seeing any fast-forward buttons on our day planners." Yet, if you compare clocks, one in orbit and one on the ground, and keep them sync-checked with painful precision, the difference begins to emerge. It is tiny, delicate, like a whispered secret between space-time and the station. When the astronaut returns home, The clocks disagree by the smallest measurable sliver. Time has stretched and compressed just enough to prove its flexibility without making a spectacle of itself. What makes this even more delightful is that the space station is humanity's accidental time laboratory. It was designed for research, yes, biology, physics, engineering, Earth observation, but tucked quietly behind all those goals is the constant truth that every astronaut is also a test subject for how the universe handles clocks in motion. Their orbit ensures they live inside competing forces every second of their journey. Gravity pulls one way, velocity pulls another, and time threads itself between them like a diplomat trying to keep both sides from raising their voices. And so, the astronauts, heroic, tired, curious, floating, become ambassadors of how subtly time shifts when exposed to motion and weakened gravity. They return to Earth looking exactly like themselves, carrying stories of glowing auroras and sunrises that come every 90 minutes, unaware that the universe has been quietly adjusting their personal tempo. The difference is small, but it matters. It matters because it reminds us that time is not rigid. It bends, it flexes, it flows differently depending on where you are and how you move. Even if all you are doing is orbiting Earth in a shiny habitat that circles the planet 16 times a day. And though astronauts may laugh at the idea of a time tax, the cosmos keeps collecting it, one gentle, invisible millisecond at a time. There is a secret the universe keeps tucked behind every burst of speed, every accelerative push, every moment someone or something decides to move faster than a casual stroll. The secret is this: speed demands payment, not in cash, not in fuel alone, not even in sweat or engineering headaches. No, the universe charges a stranger fee. Every time you add speed, you owe time, and time always collects. To make sense of this cosmic exchange, imagine standing in line at a coffee shop. You order something simple, a plain drink, nothing extravagant, and the universe nods approvingly. But the moment you start adding extras, things change. You tack on a flavor shot, then a swirl, then a drizzle made of ingredients whose names sound like they require laboratory equipment. Suddenly, the price climbs. That is what adding speed is like. Ordinary motion is cheap. High-speed motion, however, is a deluxe order, and you pay for it with warped time whether you intended to or not. At low speeds, energy behaves politely. If you want to double your speed, you roughly double the energy. It is a neat, manageable relationship, like a friendly handshake between physics and your expectations. But as you creep toward extreme speeds, close to the cosmic limit, the universe stops being gentle. The energy requirement skyrockets. You can push harder and harder, but the payoff shrinks. Instead of granting you more speed, the universe begins redirecting all that extra energy into other changes. Changes in your mass, changes in your time, changes in how reality treats your motion. The reason lies in the strange relationship between energy, motion, and the underlying structure of space-time. To accelerate something, you must invest energy. But when you accelerate something toward light speed, the universe resists in the most elegant, stubborn way imaginable. It does not let you simply keep increasing speed at a normal rate. Instead, it reroutes your energy into warping your experience of time. The more energy you pour in, the slower your personal time becomes compared to the outside world. It is like ordering that fancy coffee and discovering the barista took your extra dollars and used them to adjust the lighting instead. Unexpected, but very real. This relationship becomes obvious when you look closely at what happens to objects as their speed increases. At modest speeds, motion is straightforward. Velocity goes up, energy goes up, and nothing dramatic happens to time. But once you nudge toward the realm of extreme velocities, the graph of energy versus speed begins to curve sharply upward, like a hill that turns into a cliff. Climbing that cliff becomes nearly impossible. You push and push, but the universe redirects your effort into slowing your personal clock, thickening your seconds until they become stretched, syrupy versions of the seconds experienced by everyone else. Imagine driving a car that needs twice as much fuel to speed up from 20 miles per hour to 25 miles per hour, but 10 times as much to speed up from 95 to 96. Eventually, the car would reach a point where pressing the gas pedal simply makes the engine groan without giving you much more speed. That is what approaching light speed is like. The universe does not allow you to break the limit, so instead it channels your energetic ambition into time distortion. There is a poetic stubbornness to it. You pour more and more energy into your motion, and instead of rewarding you with velocity, the universe leans back and says, "You can slow your time instead. That is the best I can offer." It is not a negotiation. It is a rule etched into the geometry of existence. What makes this especially fascinating is that the trade-off is unavoidable. You cannot choose to opt out of the time-warping fee. Even if you complain to the cosmic manager, file a universal request form, or politely insist you only wanted speed, the universe will answer with a gentle but firm, "Too bad." Time will slow for you. It does not matter whether you are a spaceship, a beam of charged particles, or an unfortunate human strapped into an experimental propulsion pod. The same rule holds. To understand why this happens, picture the structure of spacetime as a grid stretched across reality. At slow speeds, you move through the grid with ease, but the faster you try to push across it, the more the grid compresses in the direction you travel. The act of pushing harder begins to squeeze time itself, forcing your seconds to lengthen. The grid does this not out of reluctance, but out of necessity. If it did not bend, the laws governing cause, effect, and the speed of light would collapse into chaos. This warping of time is not just a theoretical flourish. It has practical implications for anything that requires enormous speed. The energy needed to achieve significantly high-velocity balloons so dramatically that even the largest engines humans can build fall far short of the requirement. And even if you could generate the energy, the reward would not be speed alone. Much of that energy would be spent bending time, thickening your seconds into something that does not match the rhythm of the universe left behind. This is why achieving light speed is impossible for anything with mass. The energy demanded does not plateau. It ascends without limit. like a staircase whose final step is infinitely far away. No matter how much energy you add, the universe redirects your effort into warping time further and further, slowing your personal experience to preserve the order of physical law. It is almost comical in a cosmic way. You attempt to rush through the universe as fast as possible, and the universe responds by slowing you down, not in speed, but in aging. It stretches your seconds like dough, making your experience of time less hurried, even though you are racing faster than almost anything that has ever existed. So, motion and energy share a relationship built on negotiation and constraint. The more you insist on speed, the more the universe insists on altering time. You might set out on your journey determined to conquer velocity, but you end up discovering that time itself has been adjusting behind the scenes, charging you a cost you cannot avoid. In the end, adding speed is indeed like ordering that fancy coffee. You get what you asked for, to a degree, but you also get an unexpected bill, warped time, stretched seconds, and a reminder that in this universe, nothing accelerates for free. Time collects its fee with quiet confidence, ensuring that the cosmic limit remains intact, no matter how much energy you are willing to spend. If you want to watch time dilation create real-world chaos, you do not need a spaceship racing through galaxies or a laboratory buzzing with exotic particles. All you need is a smartphone with a navigation app and a few satellites calmly orbiting Earth, doing their best to avoid becoming accidental comedians. Because without careful correction, GPS satellites would deliver directions so wildly wrong that you might end up in the next town when you were aiming for the grocery store. Time dilation is the invisible puppeteer behind this, pulling the strings to keep your map from becoming a slapstick routine of cosmic misunderstandings. Start by picturing a GPS satellite as a metal timekeeper drifting high above Earth, steadily circling the planet like a patient librarian checking that everyone's clocks match. These satellites orbit at high speed and at an altitude where Earth's gravity relaxes enough to let them glide with remarkable smoothness. Each one carries an atomic clock, a clock so precise that it could out-discipline even the most fastidious human scheduler. These clocks are the heart of the entire system. They broadcast their ticking to Earth, and your phone listens, triangulating signals to figure out where you are. The idea sounds simple. Satellite tells time, your device listens, and together they figure out your location like two friends comparing notes. But the universe, with its flair for bending time, refuses to let the process stay simple. Those satellites are not living in the same version of time as the devices receiving their signals on the ground. They orbit at high speeds, feeling the tug of motion. At the same time, they reside high above Earth's surface, where gravity's hold is weaker. This sets up a tension that bends their experience of time in subtle but important ways. First, their speed tries to slow down their onboard clocks. Just like astronauts on the station, though at a different magnitude, the satellite's rapid motion tugs at their seconds, stretching them slightly. If this were the only effect, the clocks on board would drift behind Earth clocks. But the second effect pushes in the opposite direction. Up there, gravity's grip is looser, and when gravity relaxes, time speeds up. That means the satellite's clocks try to run a little fast. These two influences, motion and gravity, do not balance perfectly. The gravitational effect wins. So if you launched a satellite, let its clock tick freely, and never adjusted it, that clock would run faster than every clock on Earth. Just a tiny bit, but enough that over a single day, the difference would grow into a disastrous mismatch. Your phone relies on the assumption that every tick is exactly where it should be in the schedule. If a clock up there runs even slightly off tempo, your calculated position on Earth shifts dramatically. It would not shift politely either. You would not merely drift a few meters off course. You might find your GPS insisting that your car is parked a stadium length away from where it actually sits. Drive with that kind of navigation, and you would turn into someone who appears to deliberately ignore street signs, barreling into the wrong lane while yelling, "The satellite told me to." The system would be so inaccurate that even simple tasks, like walking to a cafe, would become accidental treasure hunts, with your phone dropping location pins like confetti. Thankfully, the engineers who built GPS knew the universe had these time-bending habits. They accounted for them before the first satellite ever left the launch pad. Each satellite's clock is intentionally offset to tick at the wrong rate, a preemptive correction. Once in orbit, the effects of time dilation slow and speed the ticks just enough to bring them back in sync with clocks on Earth. It is like sending someone a watch that is purposely set a bit off, knowing that when they climb a mountain and walk very fast, the watch will magically correct itself and match everyone at sea level. Even with the built-in correction, the satellites still need constant tuning. Ground stations around the world keep an eye on them, adjusting their timing so that every satellite agrees on what a second means. The universe may bend time as part of its ongoing performance, but human engineers have learned to keep the choreography intact. What makes this story so delightful is how unassuming GPS looks on the outside. You pull out your phone and see a little blue dot showing where you are. You tap a location, and the map draws a line as if it were nothing more than digital ink. But behind that simple interface is a cosmic tug-of-war, clocks battling gravity and motion, signals racing down from space, and tiny bits of time being bent, corrected, rebent, and recorrected every moment. If humans had ignored the effects of time dilation, GPS would have been a comedy of errors. Airplanes would wander off their routes, ships would drift from their destinations, emergency teams might arrive at locations where nothing was happening. Your food delivery driver might end up 2 neighborhoods away, insisting the app promised this was correct. The entire system would collapse into chaos, not because of bad software or poor antennas, but because the universe insists time runs differently up there. And yet, in the midst of all this complexity, everything works. Your phone speaks to satellites. The satellites whisper back. Clocks tick in different frames of reference, but remain perfectly harmonized thanks to constant monitoring and correction. It is a quiet triumph, a sign that humans can build technology sophisticated enough to negotiate with reality's quirks. So the next time your GPS flawlessly guides you through a maze of streets, remember that the real hero of that moment is time dilation, or rather, the relentless work of keeping time dilation from turning the whole system into a comedy sketch. Those satellites are living in their own timeline, one that marches ahead slightly faster than ours, and every second the universe tries to twist that difference wider. But with careful tuning, GPS stays accurate, faithful, and wonderfully useful. A partnership between human engineering and the flexing fabric of space-time. There are moments in life when two people witness the same event and somehow walk away with wildly different recollections. One swears the cat knocked over the vase, the other insists the wind did it. Neither is lying. Their brains simply filed the memory in different ways. The universe, it turns out, does something remarkably similar, except its disagreements are not about houseplants or broken glass. They are about the fundamental sequencing of reality itself. Motion changes how observers experience events, and the result is a cosmic version of that stubborn friend who folds their arms and says, "That is not how it happened, and I would know." Imagine two observers watching a dramatic but harmless event, a pair of lights flashing at opposite ends of a long spaceship. If both observers stand still in the same frame, they agree on when the flashes occur. But if one observer is moving, even smoothly, even without feeling motion, the order of the flashes changes for them. What was simultaneous for one becomes mismatched for the other. It is not an optical illusion. It is not a trick of perception. It is the universe adjusting the story to match the observer's motion. To understand why, picture the fabric of space-time as a sprawling sheet spread across a table. Events, flashes, footsteps, conversations are like pins stuck into the sheet at specific places. Motion in this metaphor is the act of pulling or pushing on the sheet slightly. A moving observer slides through space-time along a different path, tugging the geometry just enough that the order of events shifts. The pins do not move, but the angle from which they are viewed changes, and with it, the understanding of which pin came first. This makes simultaneity, the idea that two events happen at the same time, a slippery concept. Humans treat simultaneity like a universal truth, the same for all people everywhere. The universe smirks and replies, "That is adorable, but no." When two observers move differently, each one carves a unique trajectory through space-time, and that path shapes how time itself unfolds for them. A pair of flashes that appear perfectly synchronized for someone standing still will appear staggered for someone rushing past. This disagreement is not a minor quibble, it is baked deeply into the rules of reality. The speed of light sets the boundaries for how information travels, and observers in motion encounter that information at different angles and intervals. Because their motion affects how distances contract and how time stretches, it also affects when information reaches them. They literally inhabit different slices of space-time. Their now is tilted relative to one another. You might imagine two people watching a parade from different points along the street. One stands near the start, the other near the middle. The band begins to play. The first person hears it immediately, while the second hears it moments later. But this delay is not what relativity is talking about. Relativity goes deeper. It is not about sound arriving at different times. It is about the universe writing the sequence of events differently for each observer based on their motion. Even if they could see the entire parade at once, like a bird hovering above, their moving or stationary state would still alter how the parade's timeline arranges itself. Consider a thought experiment. You are standing on a platform while a train passes at incredible speed. Someone on the train switches on a flashlight aimed at the ceiling. Inside the train, the light moves straight up and down. On the platform, however, you see the light follow a diagonal path because the train is moving forward while the beam is climbing. Both views are correct, but they imply different measurements of time. The moving observer sees the light cover a shorter distance. The stationary observer sees it travel farther. Because the speed of light cannot change, both observers must assign different time intervals to the event. These different time intervals reshape their understanding of what happened when. What appears to be a simple disagreement over perspective is actually the universe recalculating time and distance in real time. Motion reframes the geometry of reality. It stretches certain intervals, compresses others, and rearranges the chronological order of distant events. Two observers who attempt to compare notes afterward will discover their timelines do not quite match. They have not misremembered. Their memories are faithful to their own trajectory through space-time. This leads to some wonderfully bizarre consequences. Imagine a cosmic fireworks display where several bursts explode across a vast region. One observer floating peacefully might claim the red burst happened first, followed by the blue. Another observer, rushing past in a spacecraft, might insist the blue burst clearly preceded the red. Neither is mistaken. The universe simply presents them with different time orders because their motions carve distinct slices through space-time. The universe is not being mischievous for its own amusement. It is following its own rules with unbreakable loyalty. Once you accept that space-time is not rigid but malleable, the disagreements become unavoidable. Observers in relative motion cannot share a single, universal timeline. They each live inside a tilted version of reality where events can shuffle places depending on how they race through the cosmos. In this sense, motion makes the universe behave like that friend who confidently says, "That is not how it happened. Only this time the friend has the full backing of physics." They are not being stubborn. They are simply living in a timeline that has been slanted, stretched, or compressed by their speed. You can argue all you want, but the universe will quietly shrug and say, "You are both right. You just traveled different paths." And suddenly, the universe feels less like a stern judge delivering absolute orders and more like a flexible storyteller weaving parallel narratives that all fit the rules but differ in detail. Motion creates alternative versions of the same event, not through fantasy, but through geometry. Observers disagree, not because of faulty perception, but because space-time shapes itself differently around each of them. In this way, the cosmos reveals something deeply surprising. The truth of events is not singular. It depends on how you move. And in the grand theater of reality, everyone watches the same play, but no two seats offer exactly the same view. Imagine stepping into a ship designed not for ordinary travel, but for slipping through time as gracefully as a hand through water. It is sleek, silent, and patient, waiting for you to climb inside and hand over your future. This ship is built for speed. Not airline speed, not rocket speed, but a kind of velocity that brushes the edge of light itself. The moment you strap in, you are no longer planning a trip. You are planning a temporal pivot, a leap into a future that the rest of humanity will reach only after centuries of birthdays, revolutions, and forgotten trends. The engines hum to life, offering no hint of the spectacle they are about to unleash. There is no science fiction roar, no dramatic shaking, just a steady vibration, as if the ship is saying, "Do not worry, I have done this 1,000 times in simulations." When the acceleration begins, you feel a gentle push. Nothing too alarming, because the ship is designed to cradle you like a treasured seed. As its speed builds, something astonishing happens, not to the stars outside, but to time itself. At first, the difference is tiny, almost laughably small. 1 second for you becomes a hair longer compared to the clocks back on Earth. But the ship continues accelerating, climbing through speed thresholds too quick for ordinary physics to keep up with. Soon the change grows noticeable, not in your daily experience, but in the math that governs your existence. For every hour that passes on your ship, perhaps several hours pass on Earth, then days, then years. Eventually, the ratio becomes astonishing. Your ship settles into a cruising velocity, where 1 day for you might equal a century back home. Yet inside, nothing feels strange. That is the eerie beauty of high-speed travel. Your heart beats at its normal rhythm. Your thoughts flow smoothly. You drink water, stretch your legs, check the ship's instruments. Each act feels as ordinary as brushing your teeth on a Tuesday morning. You do not feel time bending. It bends quietly, deferentially, bending around you like a curtain parting for someone who walks with quiet purpose. Outside your windows, space unfolds differently. Stars seem to cluster in the direction you are moving, crowded together like curious onlookers pressing toward a stage. Behind you, they seem to thin out, their light stretched until it fades into softer hues. The universe bends not out of whimsy, but because your motion reshapes the way light reaches you. Everything ahead becomes a compressed tapestry of brilliance. Everything behind becomes a stretched whisper. And as all this unfolds, Earth continues its patient dance around the sun. To the people you left behind, time moves at its familiar pace. Seasons change. Generations rise and fall. Languages evolve. Cities expand and crumble. Entire histories begin and end, while you pass a single afternoon adjusting navigation settings or enjoying a simple meal. Imagine checking your ship's external timeline display, a feature designed so you do not lose track of Earth's unfolding story. You glance at the readout and see that the year back home has leapt forward by decades. You blink, you check again. Yes, it is correct. While you brewed a cup of tea, empires shifted, technologies advanced, and the world reinvented itself several times over. This realization might hit you like a quiet tidal wave. You have become a visitor from the past, traveling not just through space, but through time. You are suspended between eras, intact and unchanged, while the universe ages around you with breathtaking speed. And yet you feel neither heroic nor tragic. You simply exist in a state the universe allows, a state where motion reshapes time into something pliable. Of course, the ship does not fly forever. Eventually, you must turn around. The deceleration begins as gently as the acceleration did, easing you back into a timeline that grows less distorted with every fraction of light speed you surrender. When the ship slows enough, the difference between your time and Earth time shrinks from wild leaps to polite nudges. The stars return to their familiar spacing. Your seconds begin syncing more closely with the universe outside. Then comes the moment of return. The ship dips through Earth's atmosphere, your heartbeat quickening as continents and oceans rush into view. You land near a place that feels vaguely familiar, but not quite right, like a dream of home rather than home itself. The air smells the same, but the skyline has changed. There are buildings where none existed, vehicles that hum quietly without exhaust, languages that have drifted subtly away from the versions you knew. People greet you with wide eyes, as though a figure from legend has stepped out of myth. They marvel at your age, or rather your lack of it. Stories of your departure have survived through generations. Your journey has become part of the cultural memory, the kind parents tell children when describing the wonders of science. And now here you stand, barely older, blinking in confusion at a world that has moved on without your permission. The emotional weight settles slowly. Everyone you once knew is gone. The people who welcome you are descendants of the descendants of those you met before leaving. They treat you with reverence, but you feel a quiet ache, a recognition that you have traded your own timeline for the future's. Yet there is something beautiful about it too. You have crossed centuries in the span of a personal breath. You have witnessed what time dilation truly means, not as an abstract equation, but as a lived experience. You have become a bridge between eras, living proof that motion can sculpt the flow of time so profoundly that you effectively leapfrog through history. And as you walk among the people of this new world, learning their customs, hearing their music, tasting new flavors, you realize that your journey was not just a voyage through space. It was a conversation with time itself, a conversation in which time listened, paused, and waited for you while the universe carried on ahead. If you have ever wished your birthday lasted longer, maybe because the cake was perfect, or the presents were unusually thoughtful, or someone finally remembered the exact kind of frosting you like, then time dilation might sound like a cosmic loophole. After all, if racing through the universe can slow your personal clock, why not stretch your birthday into something luxurious and long, like a holiday weekend that refuses to end? It is a delightful idea. And it is also the universe's cue to lean over the counter, raise one eyebrow, and say, "Nice try, but absolutely not." The temptation comes from a simple observation. When you move fast enough, your seconds lengthen, your time slows down. That means you age more slowly, perceive events in the same rhythm as always, and experience life at your own pace, while the outside world sprints ahead. So you might think, if I hop in a ship, zip around at high velocity, and then loop back home, my birthday could last longer for me. If I go fast enough, I could practically freeze it. It sounds like a cosmic hack, like one of those too-good-to-be-true kitchen gadgets that slices, dices, blends, and disappoints all at once. But time dilation does not work like a rewind button or a personal celebration extender. It is not designed to let you savor a single moment indefinitely. Instead, it stretches the rate at which your moments pass compared to someone else's. Your birthday does not expand internally. It is not like inflating a balloon where the inside gets more room. Instead, you stay inside a normal length day. Your thoughts, your steps, your jokes, your cake bites all unfold at their regular tempo. Nothing inside your experience slows down. It is everyone else who moves through time faster. Imagine you blow out the candles, make a wish, and then board a high-speed craft with grand ambitions. You accelerate to a velocity where your personal time is noticeably slower than Earth's. Inside the ship, the day feels like a day. You do not get bonus hours to finish leftover cake or replay the moment someone surprised you with that unexpectedly touching gift. Instead, what happens is that Earth streaks ahead in its own timeline. By the time you land again, people on the ground have long since cleaned up the party, washed the dishes, and moved on to the next batch of birthdays, possibly several years' worth. While you experienced one normal day, Earth experienced many. So from your perspective, the birthday was not extended. It just occurred in a different temporal neighborhood. Time dilation did not stretch your celebration. It pulled the rest of the world away from it like a conveyor belt speeding up while you stand still. This is the trap of trying to use physics as a personal calendar editor. Time dilation is a comparison trick, not an internal modification. Your experience remains internally faithful. Your seconds do not feel slower. You do not talk slower, or blink slower, or unpack gifts slower. What changes is the tempo relative to everyone else. Your birthday remains the same size. It just becomes separated from the normal march of the universe in a slightly dramatic way. There is another wrinkle in the plan, one the universe seems particularly proud of. To even begin to slow your time enough to matter, you would need extreme impractical speed. Not running really fast speed, not airplane doing its best after 2 espressos speed. You need skimming the edge of light speed, which requires energy levels that make rockets look like enthusiastic sparklers. So even if you wanted to cheat the calendar, you would need a machine powerful enough to bend the physics of your seconds in a meaningful way. Humans are nowhere near that level yet. And even when they are, birthdays may still not be the priority. But let us imagine the technology exists. Suppose you have a ship capable of staggering acceleration. You climb aboard with your party hat still slightly crooked, determined to stretch your birthday into an epic, candle-filled saga. You depart, speed up, slow your time, and after experiencing 24 normal hours, you return. The problem is that the world now sits decades in the future. Your cake is gone. Your house is gone. Your entire party probably has its own museum exhibit by now, artifacts from before she left. A day for you became a historical event for everyone else. So instead of reliving your birthday, You have accidentally turned it into a time capsule. This reveals the heart of the matter. Time dilation does not freeze your moments. It simply changes the relationship between your timeline and the timeline of others. You cannot stretch a single moment from within. You can only stretch the comparison of that moment to external clocks. Your birthday will still be 24 hours long for you. It just will not be 24 hours long for the rest of the universe. There is also the whimsical reality that if time dilation truly allowed people to relive birthdays, humanity would be swarming the cosmos in party ships, chasing eternal slices of cake like confetti-addicted moths. The universe likely foresaw this scenario and decided to enforce the rules strictly. You can move fast, you can warp time, but you cannot turn one day into many from your own viewpoint. Time dilation is a cosmic effect, not a personal indulgence, which leads us to a gentle but humbling conclusion. You cannot use motion to stretch your birthday. You cannot loop it, relive it, replay it, or coax extra hours out of it. Time dilation is a scientific marvel, but it is not a celebration extender. Your birthday is tied to your own internal rhythm, and no amount of speed will make it last longer for you. But there is a silver lining. While you cannot expand your birthday, you can appreciate it in a new way, as a day that exists entirely within your personal timeline, untouched by how fast anyone else moves. It is yours alone, self-contained, unbent by relativity, and perhaps that makes it even better. Because while time may stretch for travelers skimming the speed of light, the moments you cherish remain anchored to your own heartbeat, no faster, no slower, no matter how hard the universe tugs. So celebrate without worrying about cosmic shortcuts. There is no physics hack for replaying the perfect slice of cake, but maybe that is what makes each year's version so wonderfully worth waiting for. Picture the universe pulling back its cosmic curtains for one final, sweeping shot. Not a quiet closing scene, but a grand, wide-angle reveal of everything you have just traveled through. Space, time, motion, the strange elasticity of existence itself. All of it sprawls out like a vast landscape, shimmering with rules that are both familiar and incredibly alien. You stand at the edge of this view, realizing that you are small compared to the cosmos, but enormous in your ability to question it. And perhaps that is the real magic. Not that time bends, or that motion warps reality, but that humans have learned to notice. For most of human history, time seemed like the most steadfast companion imaginable. It flowed evenly, endlessly, like a river that never once considered renegotiating its pace. Nobody suspected that time could slow its steps or tilt its path or carry different people at different rhythms depending on how boldly they moved. But then came the realization, slow at first, then breathtaking in its implications, that time is not rigid at all. Time is woven into the same fabric as space, and that fabric is not the quiet, obedient cloth we imagined. It stretches, it flexes, it twists, sometimes gently, sometimes dramatically, depending on how fast you dare to travel or how close you wander to gravity's deep wells. If you imagine spacetime as a grand stage, it is a stage with shifting floorboards. Step lightly, and the boards stay steady. Race across them, and suddenly the planks tilt, rearrange, and stretch your footsteps, all while maintaining a choreography so perfect you never feel the motion beneath you. The universe performs this dance tirelessly, applying the same rules to everyone and everything, from the tiniest particles to the most ambitious explorers. You may never sense the bending of time firsthand, not the way you sense heat or gravity or the sting of a cold breeze, but the effects ripple beneath every moment you live. What makes this conclusion cinematic is that the camera now pans not across galaxies or nebulae, but across the human mind. Because the real wonder is not that space-time bends, it is that people noticed the bending. Humans looked at starlight, at clocks, at motion, at particles that flash into being and vanish again, and somehow pieced together the hidden flexibility of the universe. They turned thought experiments into equations, equations into experiments, and experiments into technologies that quietly depend on time's changing tempo. It is a breathtaking achievement, the kind that future civilizations, whether human or something else, might look back on and say, that was the moment they began to understand the stage they were standing on. The camera moves again, drifting across the tapestry of motion itself. The universe has never been static. Everything moves. Planets, moons, stars, galaxies, light, particles, humans. Even when you feel still, you are riding Earth's rotation, Earth's orbit, the solar system's drift, and the galaxy's slow roll through cosmic darkness. You have always been in motion. You have always been tugging at space-time, coaxing it to shift its weight beneath your feet. The dance has been happening around you since before you existed, and it will continue long after you are gone. Yet what truly stands out is not that motion shapes time, but that curiosity shapes understanding. You do not need to travel at high velocity to feel the thrill of it. The wonder comes from knowing that reality has hidden layers, layers you can explore with thought, imagination, and the occasional expensive machine that hurls particles around at incredible speeds. The beauty is not in outrunning light or slipping between centuries, but in recognizing how deeply connected everything is. Motion changes time, gravity folds space-time, and perception depends on where you stand and how you travel. And through all of it, the human mind continues its relentless sprint toward understanding. The music swells, metaphorically, unless you are the type who reads with a soundtrack, as the story reaches its final turn. You realize something profound. Even though time can stretch, shrink, and warp, curiosity does not slow down for anyone. It races ahead, always a step beyond the present moment, tugging humanity forward the way gravity tugs planets into orbit. Curiosity is the engine that accelerates civilization, the fuel that keeps people asking, what happens if we push a little harder, look a little closer, go a little faster? And so the chapter closes not with certainty, but with invitation. Time dilation is just one corner of the cosmic puzzle. There are still mysteries waiting in the shadows, dark matter humming in unseen filaments, black holes twisting space-time like a cosmic whirlpool, distant galaxies fleeing farther than we can comprehend, and quantum realms that ripple with probabilities instead of certainties. Every answer sparks another question, and every question nudges humanity into new directions of discovery. Perhaps that is the real cinematic ending, not a perfect resolution, but the quiet thrill of standing at the edge of the known universe with a map that is mostly blank. Humans have learned that time is not the same everywhere, that motion reshapes existence, and that the universe is far stranger and more beautiful than the straightforward clockwork model once imagined. And instead of shrinking from that strangeness, people lean toward it. They build instruments, they launch missions, they dream, time bends, space-time flexes, motion rewrites the script. But curiosity outruns everything, even the limits the universe sets.